Let's see. There we go. Hey, cool. Welcome back to Demo Studio for another weekly live stream. As always, my name is Nick. Mungo, I saw you said hello, so hello to you specifically as well. So for this week, we're going to finish up the maintenance for the Pro 2s. And then before I get working on the machines, I did want to kind of go over a few more of like the best practices for the machines themselves, and getting into a few kind of specific things that you can do for just making sure the upkeep is a lot easier. A couple of those things specifically, we have a quick list I want to get up here. But things like making the hot ends available with the individual nozzles themselves. The process for uninstalling and reinstalling in a nozzle isn't too invasive, but it does add extra steps. And what we'll be going over later, making sure that things are properly installed. If you're really, really good and just on top of making sure that the nozzles are tightened in properly, it's typically not an issue. But if you have the hot ends already pre-installed, everything is correctly installed, you don't need to keep that in mind. Why run the risk every time you're going to swap it? It's better to just have the hot ends with the nozzles installed. And it makes the swapping process a lot easier. So if you're going from a 0.4 to a 0.6 to a 0.8, or just a brass to a hardened, while it's not always required to run certain materials through certain nozzles, a hardened nozzle will still work for standard PLA or ABS, just any pure material. It typically is better to kind of keep things with the same material, and it's just going to increase the overall lifetime of all the nozzles if you're going to be swapping them out like that. Just keeping them on the hot end makes it a lot easier to make that quick swap rather than needing to reinstall the nozzles every single time. Next one is actually storing the filaments properly. So in general, for all of the common materials, PLA, ABS, PETG, they typically don't absorb too much moisture from being left out, at least in my experience. I know it varies from material to material and brand to brand. But every filament is going to benefit in some way from being properly stored and pretty frequently dried, I would say. Again, for PLA, PETG, ABS, I would just dry them more kind of as needed. But for things like a PVA or a nylon material, those I would always either print out of the print dry or dry the day before, and then print out of a poly box or a low humidity chamber. And then anytime those aren't being used, if you don't have the time to re-dry them before they're being used again, you're definitely going to want to keep those stored in a vacuum silicone chamber with the desiccants, so that way they don't absorb any moisture while they're just being stored. And that way they'll be easier to kind of keep up, and then just put them back in the machine when they're being run again. So I did also just talk about the kind of dry filaments, and then if necessary, keeping them cool and dry and in a well-storage place. One thing that's actually probably really good for filament storage, if you switch back to me really quick, we do make the carts that come with, or not come with, but they're available for Pro 2 Plus, Pro 2, and E2. But all of these have kind of storage chambers down here, so you can store your filament in there. And then also, the upper tray is all a custom cutout for all of our stuff. This is actually the older version of the tray. The newer version, I believe, is over on the other E2 cart, so I can show that. But I did redesign that cart tray, so very proud of that for myself. But yeah, so proper filament storage is key, and drying them if necessary, depending on the materials. Yeah, and then using the cart, so organizing all the filaments, all the spare parts. Like I said, everything is kind of custom cut out. So you'll be able to have spaces for all of the tools. And then actually, while we are on the subject, let's see. Yeah, I can get a good view over here. The newer tray design. Oh man, I think I actually am working on a much different card, but the other tray designs are essentially made for all the parts you would need, to include things like the ratchet, flush cutters, tweezers, keeping all those properly stored. And there's also spaces for intentionally printing out various sections of it. So they're designed to be customized even more specifically for whatever you guys are using. So that's kind of just a brief thing on best practices, nozzle swaps, material storage, things like that. And then getting into the actual maintenance, we can start working on our Pro2 Plus over here. So I will be going in order of the nozzle swaps, or the hot ends. We'll remove those. We'll swap the nozzles on those. It's not always required. The stock hot ends will come with a 0.4mm brass. So if you're sticking with that nozzle size and that nozzle type, you don't need to do any swap when you're just updating those. But I'll go through the swap as well. Then we'll move on to replacing the actual build tech. So if you're going to refresh the build surface, after that, the gantry system, and then we'll also cover the process for replacing the Hepa filter in the back. We do recommend swapping that out every 6 months if you're printing for materials that are giving off a lot of fumes and particulates. ABS in particular is going to be the kind of biggest offender of that. So if you're printing a lot of ABS, then you're looking at swapping it out closer to 6 months. Otherwise, for things that don't typically need to be filtered out, you know, PLA, TPU, then you can go ahead and swap it out closer to a year or a year and a half, but the quickest would be 6 months just to be really on top of it. And then another thing, the updates for the machines themselves. The software is pretty important to keep that up to date just so things are going to always be working properly. The process for updating the machines is pretty simple. We have a link for our download page. So if you just go onto that website and then you want to download the MCB firmware, motion control board firmware, and then also the Raise Touch firmware. There are two different softwares that the machine runs, and you'll need to update them both. But the process for updating the Raise Touch firmware, everything on the webpage also specifies what it's for and which machine it is for. That is also very important. There's listings for the E2 firmware, the N2 firmware, and the Pro2 firmware. So you want to make sure that you are uploading the correct firmware to the correct type of machine. But actually installing the firmware updates for the touchscreen and for Raise Touch, you would just download that file and then put it onto the root folder of a USB drive, plug that into the side of the screen, and then restart the machine. Once it turns back on, it's going to recognize that update file and then prompt if you want to run the update. You can go ahead and agree, start the update, and then it'll run on its own. Then it'll boot back up into the main start screen, and you'll have your fully working machine again. For the motion controller board update, that actually does run through the touchscreen itself. So you would still take that update file, put it onto USB drive, then plug it into the side of the screen. But then to actually start that update, you'll need to go into print, USB storage, open the folder for that, and then it'll have an icon that's like a set of 2 gears. You'll go ahead and tap that, select that, and then kind of it'll start up kind of like a print will, but then that'll just ask for updating the MCB. That'll run through its own process, and then once that update finishes, then you'll have an updated MCB. Just updating those 2 components is all you need to keep basically up on task for making sure that you're running the newest software. And then in the hot end replacements, we'll go ahead and get into the actual nuts and bolts of the machine. All right, so looking at our hot end assembly, excuse me 1 second while I grab my tools. The main things that need to come off, the main things blocking it for the time being, are going to be the 2 side fans. So we'll need to get both of those off, and then the hot ends will come off individually, and then the heater rods and thermocouplers inside those. It's essentially the same exact process for both hot ends. It's just reflected on each side, but I'll go ahead and do both of them. So working with cold hot ends here, we'll need to remove the bolts for the side fans, and there are 4 bolts on each side. The 2 front ones will go through the duct for the fan, so we'll want to remove those. And then the 2 in the back actually hold on the rest of the assembly for the shifting mechanism for the hot ends. So we actually don't want to mess with those, so we don't have to do anything with that system. But just removing those 2 bolts in the front, and then we can move that off to the side. I will typically, usually hangs down with the cable there, but we don't want the fans like that, so I'll typically loop them up and over the gantry rod, just so that way everything's out of the way. Then with the hot ends, there's an upper collet in there. You kind of see a little bit. There's a single hex screw in there. That's going to be the same size as the fan grub screws. And then once I loosen that, the entire hot end assembly just drops out, and we only have the heater rod and thermocouplers on. So I'll go ahead and run that for the other side as well. And then in some cases, it's a bit rarer. If you are working with a hot end and the grub screws for the heater rod and thermocoupler are too tight, or you just cannot get them loose, it is possible to preheat them via the touchscreen, and then I would just, without dropping them from here, loosen all of the grub screws while they're in place just to break tension. And then once the tension is broken, you're going to want to reset those hot ends back to 0 or turn the machine off again. That's very, very important, because you do not want to have a situation where you pull out the heater rod and the thermocoupler while it is being heated. That is then going to cause the exposed heater rod to start to heat up on its own while it's disconnected from the sensor. And then the machine's going to throw an error, so it will stop itself. But it's always best to avoid doing that. So just in any case, anytime you're removing the hot end from the heater rod and thermocoupler, hot end temperature should be set to 0 or the machine should be off. But those just slide right out. Again, we'll do the same thing for the other side. And then while it's like this, we'll move into the nozzle swap. Got both of our hot ends here. One thing that I do kind of want to mention while we are here, and that I can go over it again while we're reinstalling them, the silicone socks that come on the nozzles help with a little bit of insulation. They also keep things really clean. I know these are kind of a little bit sensitive to being damaged or scraped, so they won't always last the entire lifetime of the hot end itself. In some cases, you can, or in most cases, you can run the hot end without the silicone cover, but then it tends to build up some material as well. If you do get material buildup on the hot ends, then while they are reinstalled, you can go ahead and heat them up again with the touchscreen, and then I will go ahead and use a wire brush to clean off any extra residue. The tweezers will work just as well to scrape off any material if you don't happen to have a wire brush, but that's going to be one of the better ways to do that, just to brush off the nozzle. Or additionally, if you wanted to have spare socks on hand, just to make sure things are always going to be together, we do sell the socks on the website, come in a pack of 3, and we just use that to essentially recover any hot end that has had its sock damaged. So they do have replacements for those. On the nozzle replacement, bring ourselves over here. Hello. It's getting into the actual nozzle swap. On the hot end assembly, we have the upper heatsink, the throat tube, heat block, and the nozzle itself. Just running on a quick disassembly here, it is possible to take off the heatsink or just loosen it so that we can still rotate it. That will come into play a little bit later. But just loosening that, I now have a loose heatsink, and that can be removed. So we have the individual heatsink portion, the throat tube, the heat block, and the nozzle. To remove the nozzle, I will go ahead and take the largest Allen key from the set that comes with the machine. We'll run that through the hole for the heater rod. This just gives me a lot of extra leverage on the heat block itself, so while I'm actually loosening that, it'll be easier to get the nozzle off. And then it's an 8mm socket in order to remove that nozzle. So just running this here, I'll switch my side over, then break tension. So now I can go ahead and remove the nozzle itself. And then we have just the heat block. So one thing that is very important is making sure that the throat tube and nozzle seat into each other within the heat block. I cannot stress this enough that you do want to make sure that you're tightening against the threads of the throat tube rather than up against the block itself. So just having the throat tube assembly with the heatsink, the nozzle itself is kind of chamfered in such a way that the outer flange here kind of seats into that nozzle. So when we have the throat tube and the nozzle threads together, we want to make sure that we are tightening them into each other rather than tightening the nozzle just against the base of the block. So if I were to install this in without the throat tube, it would go all the way down. It would tighten up against the base of the block, and then there's no gap or anything between the rim of the nozzle and the base of the heat block. We actually want to ensure that there's a gap there when we reinstall with the throat tube in there to make sure that we are tightening against the threads, and that's creating a proper seal. So we should have full tension and a gap between the lip of the nozzle and the base of the block. But I am going to upgrade this nozzle. We're going into just a nickel-plated brass. So slightly more resistance, but not as resistive as the hardened tool steel. So there are two different nozzles on the website. The WS2 coated ones are going to last significantly longer than the nickel-plated brass ones. But if you're just going to be using, say, testing out carbon fiber, or you're not going to be using it excessively or for too long, the nickel-plated brass should hold up to that initial wear and tear and then still be good enough for a lot of the other materials. But for much longer lifetime, you want to go into the darker hardening tool steel nozzles. So then getting this installation back on, running the throat tube back down into the heat block. And I don't recommend removing the throat tube fully every time. That was just to illustrate the assembly. But we do want to have a portion where the threads of the throat tube shouldn't really be visible on top of the heat block in this gap. So we can have that far enough down. We just want to take the nozzle in and then meet it up against that throat tube. So typically, they'll go in far enough with the heatsink where it is that I don't really need to worry about the gap. If the heatsink gets adjusted or kind of gets skewed off when you are working with these here, it is possible to, we'll say, for example, I already had it at that position there. If I want to increase where this meets with the throat or with the nozzle beforehand, I can still rotate this in so it goes a little bit further down, and then tighten our nozzle back in. Allen key, ratchet that back down. Just till we get a good tension. And then with the heatsink here, I cannot reinstall that into the print head. So what I showed before with the grub screw, I can go ahead and just loosen that. So now the heatsink is loose. And then I want to make sure that it is parallel. The same grub screw at the top is parallel with the other lines. They should all be on the same face here. And then you want to have, again, that gap between the heatsink and the throat tube. Without the heatsink on there, there's a portion of it where throat tube neck gets a lot skinnier. So I'll typically line up the heat sinks with essentially with the bottom of the heatsink with just where the top of that neck starts. There you go. So then that hot end with the sock is ready to go back on the machine. And then reinstallation process is going to be pretty much the exact same steps that we just went over before, but in reverse. So we'll do heater rods and thermocouplers into the upper collet and then put those fans back on. And then we have to run through the XYZ calibrations for this. One thing to keep in mind when you are reinstalling the heater rod and thermocoupler is you always want to have the holes for the heater rod and thermocoupler towards the inside of the print head. And then the way that these go together, it's actually easiest to put them in at the same time. So I'll put these both in here, tuck in the heater rod first. Thermocoupler goes a little bit behind the heater rod, and slide them both in. And then to get the really kind of proper distance or positioning for all these components, I want to have the thermocoupler pushed all the way forward into the hot end, then tighten that one down. And then the back rim of the thermocoupler is actually low enough that it kind of stops the heater rod. So I can pull the heater rod back until it stops, and then tighten the grub screws back down. So then that's ready to go back up. And then using 2.5mm hex, tighten that collar back down. I'll go ahead and do the other ones and then get those fans back on. And then back up into our collar once again. One thing to kind of keep in mind with the collar, I will be going through this later, the Z offsets on the machines. Typically when we're calibrating the left nozzle Z offset, that'll be done with the feeler gauge, and then relative to the platform, the right nozzle is actually adjusted with the actual hot end assembly's position relative to the collar within the print head. So there's two different ways that the nozzles are adjusted for Z offsets, and we'll be seeing that color again when we do the Z offset for the right. That will be our hot end swap for the print head. Hot end and nozzle swap. So then with those, that's good to go again. We'll just leave those there until we're calibrating. And then getting into the build tack replacement. So replacing the build tack is relatively easy. I'd say maybe the hardest part is actually getting it off of the surface initially. Let's see, getting into getting the original build tack off. So you can see this one's a little worse for wear. So I do kind of want to go ahead and just get this one refreshed. But getting the build tack off is just the initial kind of first sticker portion, getting that adhesive off. I will typically start on just one of the corners and peel up that lip, and then go ahead and peel it back off of the rest of the surface. And this does take a little bit, so I'm not too worried about the plate itself. Getting this build tack off should be a little tough. Let's go ahead and work our edge down here and find areas where I can peel back this adhesive. I do kind of find that it's easiest to kind of work one side and then the other, then do the middle, and then rinse and repeat as we work it down. Once I get it down to this edge, start to let go there. the other side, and build tech it off. So then we go ahead and get rid of this. We'll get our new one in. Now, with the new kind of the raw plate here, I was putting my hands all over it for leverage, so I want to make sure that this surface is clean. So I'll go ahead and wipe this down with isopropyl, and then I'm a little bit particular about it, so I try and keep things as clean as possible, try not to touch the surface as much again. And then the process that I use for installing the build tacks initially, I'll go ahead and lay the new build tack on top of this with clips. We'll start to remove one backing of it, and then just peel off the backing and reinstall the rest of it. So since I will be laying this side down on top of this, I want to make sure that this back side is clean as well. That can pick up kind of dust pretty easily, so I'm not really worried about any grease or residue, but the dust that sticks to the back of that I want to get rid of. Heating up the plate for installing or removing the build tack is not needed. So I've got that cleaned off, and just lay it on top of this. Make sure that everything is correctly lined up. I prefer to go ahead and clip the corners, so that way I know that I'm not going to have to worry about it sliding around. Yep. And then I will pretty much always start on this corner. It's just a preference for me. I'm not sure if it's like a right-handed, left-handed thing, but wherever you want to start, it's up to you. But I'll go ahead and peel this back up, get the initial white backing off of this corner. And then once I get that started, peel back the rest of it. And it's getting these first stickers off is always a little bit tough. There you go. So now I've got part of that corner started, just the white backing coming down. I'll go ahead and peel it back, tuck it underneath so I have just this corner, and then start to lay the corner down. So you can see now that I have that kind of bottom portion folded underneath it. It's nothing but exposed adhesive and then the plate, so I can just kind of lay this down. I will take usually a straight edge or card, just something else, so we're working kind of like installing a phone protector. We're going to push this down and make sure that we get, we don't have any air bubbles or anything in there. If I were to just let this go and lay flat, it's going to trap air in there, so I want to make sure that anytime I am putting the surface down, I'm following it with this edge so I can squeeze any air out of it. I want any bubbles in the surface. I've got that first corner on. This corner is stuck. It's going to keep everything else in position. So I can go ahead and remove my clips, peel up the rest of it, and then take off the rest of our adhesive. Then from there, kind of the same process that I did just for that corner, keeping the straight edge here, and then I want to go ahead and just make sure that we're pressing everything down as we go across the surface. Make sure that I'm not getting any bubbles in the rest of the build tech here. And that's the build tech surface. And again, as always, since I've been working on it with my hands, it is covered in hand grease, so I will wipe down the initial top surface, make sure all that is clean, and now that is ready for printing. Ta-da! So next, we'll go into lubricating the X, Y, and Z gantries. Now, it doesn't need to be done too excessively, we actually recommend lubricating the gantry rods every 300 print hours, and that time can be tracked on the machine itself in the touchscreen software. On this section for where you would start prints, bottom right. On the side, there's the option for the dashboard. This actually records a lot of the history for any parts that have been run, includes the actual real print time for how long these parts took. So as compared to the estimates offered by DMaker, these will be more accurate. And then in the upper left here, it has the total print time for the machine. It's recorded in a number of kind of days, hours, minutes. So we recommend relubricating every 300 print hours, which is going to be about every 12.5 days if you're running off of this number. And then for lubricating the gantry system, I'll be doing this a little bit later, but actually on the Utilities tab, in the upper left-hand corner, there's the option to disable the motors. Hitting that icon is just going to let you know that the motors have been disabled. So then the upper motors for the X and Y gantry are not engaged. So I can go ahead and move the printhead around by hand. For the Z-axis, we will want to operate that kind of up and down to work the grease in using the touchscreen itself, but with the motors disabled, I can work the grease in the upper X and Y by hand. When we are applying the new lubricant, I want to make sure that I clean off any kind of old lubricant or grease that is on the gantry rods already. You can kind of see I've got a little bit of black buildup in the corners. That's typical. If you start to see it kind of running through the middle as it's printing, then I would probably recommend cleaning up that buildup, whether or not you've hit 300 hours. The stuff that we will use here, we always recommend a silicone based lubricating grease. The one that we use as PTFE, it's actually going to be this stuff here. So you can put a link in chat later. But first thing is making sure that we have just clean up all of the old grease off of that. And then with the printhead disabled, I can of course move the printhead a little bit, and that's going to allow me to rotate those rods. So I don't need to work up and down and around the belts. I'll just be lubricating the rods themselves. And I do try to not move the printhead too much while I'm wiping all the lubricant off. Just move it enough so I can get all of the current rods. And just the first part, going through and making sure that everything's clean. I don't need to worry too much about keeping everything else wiped down or wiping down the middle, because we'll be lubricating that, kind of working with that as we work the new lubricant in. Yep. Yeah, it does build up mostly in the corners here. So I'm just working on all of those, making sure everything is clean, getting the dust off before we work on getting the new lubricant in. And yeah, all that kind of black gunk on there, it's good to get off. And then for putting on the new lubricant, go ahead and take our grease, put a little dab on my towel here. Then I want to go ahead and apply it pretty evenly across basically the entire area. Taking this section here. And then I do want to try and get all the rods. It's not going to be too bad if I get on anything else. I'll clean that up later. And then if there's a significant amount of lubricant on the rods while it is being worked in, it'll kind of push it into the corners again. So I can just kind of re-grab it, move it around as needed. Lubricate everything in here, get underneath these middle rods, kind of move it as needed. So making sure I'm getting every side. And of course, adding new grease as I go. It's better to just do kind of small dabs on these. Make sure that I hit a lot of distance rather than doing one big glob and trying to drag that around. That's going to make much more of a mess. I don't want to miss this front one. Okay, just getting all of the side rods and then the cross rods. Then I can usually, sometimes I'll go through and do kind of multiple rounds of applying grease and working it and coming off, because even when I was applying the new stuff, I got a little bit more buildup on there. So it's really just a matter of kind of rinse and repeat until everything is properly lubricated again. Once I have a little bit of new lubricant on there, disable the motors, then I can go ahead and work it in by hand. It is going to give me a little bit more resistance that it kind of goes through that initial wave of new lubricant. And you can already see a little bit, I've got more of that buildup coming in, so I'll wipe that off. And I'll do 2 rounds. But I'll typically just do side to side, front and back. We'll hit all the corners. And then doing counterclockwise or clockwise circles. I go both directions. Keep our tubing in place. Yep. And then once everything feels like it is good and running smoothly again, that's good to go. Now there's still some grease back here. I'll go ahead and relubricate those later. But moving on to the Z-lead screws. So I would typically do want to relubricate the Z-leads as well. And then, like I mentioned before, rather than running disabling motors and moving the printhead manually, that is going to be run with the function of the touchscreen rather than doing it by hand. So essentially, it's the exact same process. Go ahead and wipe off any of the old lubricant on both of these. And there's not too much that builds up here. It typically just builds up around the upper section where the bed homes. So I want to keep those in track. And then for reapplying lubricant, the same exact process. Towel, packet of lube. Put that on, and then just going through, kind of dabbing more in here. I want to go through down kind of the entire length of these. Just make sure we're spreading it out pretty evenly. Reapply as needed. And our upper section. So, with that new lubrication on it, do you want to go ahead and work that in? So I'll go ahead and we'll just home our Z-axis. We'll get it up to the top. And then I can actually go ahead and type in the value command. So rather than having to step it all the way down to the lower section of the platform, I can go ahead and just type in for a Pro 2, probably do like 280. For a Pro 2 Plus, you can get closer to like 580. I like to just give myself a little bit of base room. But typing in whatever value here, and then just letting the build plate itself work its way down through lead screws. It'll work in lubrication. They'll probably go up and down a few times. But that's basically the same exact process you would do for the upper. It's just run from the touchscreen rather than doing it manually. Okay, so then once this goes down a little bit, we'll actually home it. So that's going to cover lubrication for the X, Y, and Z. Getting into calibrations for the new nozzles that we installed. Anytime that a hot end is removed, I'll typically recommend going through the X, Y, and Z calibrations entirely. But if you did want to just run with one of the two print heads, then really you only need to set the Z offset for that in order to do single color printing for one head. Again, if you're going to be using them both, you would calibrate both. If you're just using the left, then we can just set the Z offset. But if you did want to dual print again, then you would go through the whole XYZ. The initial calibrations for the Z offset. The Z offset distance is set with this pin assembly on the side of the bed. So there is a side thumb screw and then a lower, larger thumb screw. I'll go ahead and wait for this to home before we make any adjustments to those. But essentially, we will be working with the lower, larger thumb screw for our kind of fine-tuning adjustments. And that's going to get us kind of incrementally stepping closer and closer to the platform itself. And then we'll be using a 0.2 millimeter feeler gauge that comes with the accessories kit of the machine to gauge our nozzle distance. All right, so checking our Z offset. One thing that I will typically do whenever I'm working with a brand new nozzle, you don't know where the offset is, I can go ahead and tighten this lower thumb screw that just raises this pin assembly here. So where that tab is what actually triggers the optical end stop to set the Z home position. And the green lights above, as you can kind of see for the Y-axis end stop, those will turn on and off whenever they are triggered. So if I were to loosen this, you can see that end stop light turn back on. It's now open. So if I were to home it again, it would need to raise the bed in order to trigger that sensor. If I tighten it more, turns the light off. So now we are closer. It would need to lower the bed in order to reset that sensor. But just as a general rule of thumb, rotating this lower thumb screw towards the back of the machine is going to lower the platform Z offset. Turning it towards the front is going to bring it closer to the nozzle. And then the thumb screw on the side typically doesn't need to be adjusted. It's really more for main adjustments, as this holds in the rest of the entire pin assembly. So if we did loosen this, they are quite tight. So looks like actually this one is tight enough that I cannot loosen that one by hand, but if you can loosen this, then that entire assembly will be dropping out of there. So if you did need to make much larger adjustments, we can of course slide this whole assembly up and down, and then for these finer adjustments, just controlling it with this will give us a lot finer detail of moving that upper tab. But for any given adjustment, when it is at its home position, I want to have the nozzle that we're calibrating right now. We're calibrating the left nozzle just over the build platform. And then I'm running the feeler gauge underneath this nozzle. And I'm looking for a height where I can get the nozzle under, or I can get the feeler gauge underneath the nozzle. By passing it back and forth, I should hear it making contact. But I don't want to have the offset so low that I cannot get the feeler gauge underneath the nozzle. So I am actually quite high. I don't know if you can exactly see that gap that I'm working with right now, but it is currently not touching the feeler gauge at all. So I'd want to bring the platform closer to the nozzles. We'll go ahead and set this to its current position. I'll typically go in increments of about a quarter turn to a half turn. And then every time I make an adjustment to that thumb screw, I'll rehome the bed and then check our new Z position. So still a little bit further, we'll go ahead and make another adjustment. And then rehome. So this is going to be kind of a rinse and repeat situation for setting the offset for the left. But then once we get it to a height where, again, I can feel it on top of the feeler gauge, it is making contact. There is a little bit of tension there. Or I can hear it kind of knocking against the nozzle as it goes underneath. That's where I want to set it. And then for the right side, calibrating that Z offset, we actually keep the platform at its home position. And then, like I mentioned before, we'll drop the nozzle down onto that side position, or drop it onto the feeler gauge. Yeah, kind of what Mungo pointed out is the magnets in this corner. There are magnets on every machine. I just personally kind of work around the extra magnet tension. But if you did want to kind of move it into either the middle portion, just somewhere else where the magnets aren't going to interfere with it, that will work just as well. The only thing we really need to keep in mind, to keep track of, is the height. So I'm pretty close there. See that my nozzle is making contact with the feeler gauge now, but I can still kind of pass it underneath pretty well. There's not too much tension down there. So then what I want to do is manually shift the right hot end down. The way that that is done is by setting the temperatures for the left and right nozzle to 180. This is kind of the minimum set temperature for the nozzles to be allowed to shift. This is just to make sure that if there is any material in there, it's not going to impede the movement of the nozzles going up and down. So we really just need to have these temperatures set, and then once it gets up to temperature, to manually shift the nozzles, I'll need to go ahead and highlight whichever extruder I want to lower, and then with that extruder selected, hit either the up or down arrow, and then it will engage that extruder and run that into the lower position. One thing to keep in mind is that if we're working with the 10mm move steps, it is going to run the upper extruder motor 10mm. So this will actually slowly rotate through 10mm of length. And that can take some time. It has to run through the full thing before it does any other functions. So I will typically run at 0.1mm move steps. That way it's just moving the extruder a tiny bit, and these will shift a bit quicker. But to go to the right, having the right highlighted, and then the up or down arrow is going to engage that extruder. So now I have my right side down. I can manually shift back between left and right using those settings as needed. So right now, my right nozzle is too close. So I want to go ahead and remove our side fan, and then I'll actually be setting the right nozzle position in the print head, essentially. So we set the bed to the left nozzle, and then we'll actually set the right nozzle to the bed. Set that loose, make sure that it's as far up as it can go. Set it down on top of feeler gauge, and then tighten that back into position. So it's a little bit better. Actually, it looks like on this machine, that hot end is essentially as far up as I can get it. So it is a bit rare, but it does happen on some occasions, this being one of them. If you are working with a right hot end that will not go lower than the left, regardless of how loose it is or how much you push it up into the printhead. If that is set there, you can do the process in reverse. We'll just make these adjustments according to the right hot end, and then do the same thing. Remove the side fan, loosen the collar, and then drop the left on top of that nozzle. So it can be done either way. Typically it's done left, then right. But I'll go ahead and back this off, and then before printing, I'll go ahead and run full calibration on this. But that's the process for running the Z offsets for both hot ends. And then getting into the X and Y offsets. So this would again be primarily for dual printing or running two materials. If you are running a single extrusion print with either left or right, really only the offset needs to be set. The way that the X and Y offsets are done, there's no manual setting for those. Oh, yes, the Hepa filter. We'll be going through that process later, but essentially, in regards to how long you should wait before replacing that filter, if you're printing materials that are more likely to give off fumes and particulates, ABS in particular, then we would be looking at 6 months between replacements. Otherwise, for materials that do not need to be filtered out as heavily, like PLA, then you'd be looking at a year or a year and a half before replacing the filter. So then the offsets for the X and Y. Those are actually not set manually. Those are controlled by the touchscreen itself. The typical calibration for X and Y offsets does involve a few test prints, and those are going to be preset in Idea Maker. So you do not need to acquire the STLs for those. If you're working in Idea Maker, you already have them. And then we can just slice and then run our test prints for verifying the X and Y offsets. But the offsets themselves are going to be in the settings of the machine, and then under more settings, we'll want to go into hardware. The hardware section in here has options for networking, a lot of these in here, but what we really want done here is at the bottom, the extruders. In the extruder offset, this one has the options to enable the extruder offsets. We want to make sure that is on when we're dual printing. And then there are the options for the right extruder offset X and the right extruder offset Y. These control essentially how far the nozzles are away from each other. So that way the printhead knows if it needs to have the left nozzle here, but the right nozzle is over here, it needs to move the right nozzle 25 millimeters in X and then some distance in Y. But the values in here, like we have negative 0.2 millimeters, usually it's in tenths of a millimeter, we're making really small adjustments to fine tune in those values. So if you're starting with brand new hot ends, you would go in here and you'd set the X offset value to 25 and set the Y offset value to 0. Then in Idea Maker, you would be looking for, at the very top left corner, there's an option for File. From that drop-down menu, you'll be looking for, I believe it's File, Examples, and then Calibration. And then in that calibration menu that pops out, it'll be the Calibration Extruder Offset.idea file, I believe is the name of it. But in those files, then the 3 calibration ones, there's a 20 millimeter cube just for standard testing, the offset calibration tower, which is going to be this guy, and then the dual color cube, which is going to be this test print. And this is just kind of your final test for dual extrusion. But all you need to do is bring in that file, put it in the build volume, slice it for PLA or whichever material you're working with, and then print out the tower. And this is what we'll use for actually getting the adjustment values on the machine itself. So with this test print, what we're looking for on all the individual tiers, I might not be able to see it on the camera, but you will see it in the STL file. All of these faces have a number value, either in positive or negative. It's usually alternating. You can partially see with the 0.2 for this tier. But if the tower prints out perfectly fine, things are perfectly calibrated, you should be able to kind of run a fingernail or an edge along the tower and have it catch on every single tier. So I've actually got 2 faces here that are flush, and we'll get to that in a second. Yeah, so there's the STL files we were just pointing out. The STL files are available on the website, so if you're not working on Idea Maker, you can still get the STL for it, but it is also just pre-built into Idea Maker. Yeah, so the tower. We have the individual tiers, and I've got these 2 faces here that are flush. There's no catching on those two. And this is particularly in the Y direction. So each of these bottom tiers have a label for Y and then a label for the X offset. And what I'm looking for on the tower is any two faces that are flush, so being these two. And then these two faces are in the X direction. So you have the X of the base for these two faces. And those two are flush. So I'm looking at the two faces that are flush and then taking the value that is printed on the upper of the two flush faces. In this case, it's negative 0.3. That'll be in the X direction. So with the offsets already set to 25 and 0, 25 for X, you'll add in this upper value to the existing offset. So we'll go from 25 in X to 24.7 millimeters for our corrected X offset. And then same thing for Y. It's a little bit closer in the negative 0.2. So we'll keep that, we'll go from 0 to negative 0.2 in the Y direction for the Y face on the tower. And then with those calibrations, then with those new offsets, then we'll run the dual color cube. So that'll be the next test. Since these are all in essentially the same layer, we're printing these together. If things are perfectly calibrated, all the edges of the cube should be perfectly flush, and there should be no gaps between the four cubes here. So if I hold it up to the light and I see that there are gaps along this edge or any other portion, or these faces aren't flush, then I would go back and rerun the tower and then double check these tiers and make small adjustments as needed. Oh, yes, I believe that we had a question about the kind of spacers between the fans. Those were, I believe, updated in some newer models for the machines. So it's not an incredibly significant difference. If you did have a machine that does not have them, we do have an STL for those as well. So if you wanted to print out a set, just have a little bit of spacers. It changes the way that the fans blow onto the nozzles. So it can improve print quality a little bit, but there's not too big of a difference between the ones that do have and the ones that don't. My models are a little bit older, so they did not receive that update yet. But so that's the X, Y, and Z calibrations. The very last thing that I want to go through for kind of a fully maintained machine, again, covering the hot ends, build surface, gantry rods, nozzles, going through the XYZ calibration again. Now I'm basically ready to start printing on this machine with the new updates from the tower that can be run in dual. The last thing that I want to go through is actually replacing the filter on the back. So to get to that back filter, we will need to uninstall the back panel, which is connected to the filament side door. So that is one thing to keep in mind. It can be kind of bulky, but it's not too difficult to get this off of that upper section. So it is a Phillips head screwdriver, so I'll be working with one of those. And then this back Hepa filter fan is always on while the machine is running. So in order to just run this replacement, I'll go ahead and make sure my machine is off. And then it's just a matter of going across essentially the entire outer perimeter, removing all of the screws, and then that allows us to get the back panel off. And then again, as we are removing these bolts, it is important to make sure that we keep the panel in place so it doesn't just fall off of the machine entirely once all the screws are off. So, got our side panel. Since this back panel is connected to the door is magnetic on this kind of edge towards the front of the machine. So just want to disengage those magnets first, and then I have the entire panel here. You do want to be kind of careful. I haven't fully pulled it out yet because of the Hepa Filter cable. This cable runs directly into this back channel. So in some cases, if the Hepa Filter cable is typically an older cable, it will run down the entire length of this. So we may need to open it up and expose the entire cable channel and uninstall the connection somewhere further down in this. Some of the newer HEPA filters have the connector up in here, so I can actually just deal with that connection rather than needing to go through the entire cable channel. Get that back on really quick. Okay, so working with that. So then we can go ahead and unclip that. We have just the panel and the filter, so we can work with that outside of the machine. And then one thing to note, while we are working with the panels off, they are essentially removable for all sides. So if you are in the middle of this, working with some of the panels off, this is the best time to go ahead and go through here and clear a lot of the debris out. My favorite personal home office tool, the air can duster, is great for just going in, blowing out any debris that's left in here. And now I have a shiny new machine with no debris in it. So just things to look at while you're going through some of these replacements. Going through the actual panel itself, the new air filter does come with the full fan assembly, so we can work with just this section. And then that is going to be, again, slightly smaller Phillips screws in this upper section, but we'll just go ahead and loosen those out. And then kind of one thing to keep in mind is that they are longer bolts, so they'll go through the entire fan into the back section that holds the rest of the air filter. But once we have these 4 bolts out, then the entire assembly comes off as one unit. There is kind of essentially just the one way to replace the filter. It is important to make sure that it is facing the correct direction. And then same thing with the filter itself. So they do have a specific direction to the way that they need to be installed. With those 4 out of there, then that's the entire fan assembly. Yeah, the air filter assembly is going to be the main fan. You want to make sure that the sticker on it is facing towards the back. And then these are actually what hold the rest of the mounting in. So those bolts thread through into the top and bottom bracket. And those actually go around, you can kind of see here. These brackets have the fan lip and the filter in the bracket itself. So the bracket does go over the fan. And then the filter itself has, of course, the filter portion and then the charcoal portion. You want to make sure that the charcoal is on the fan itself, on the side without the sticker, and that the sticker faces towards the back of the machine. But again, these do come kind of all as the full assembly with the fan, so the filter and the fan should already be in their correct orientation. Go ahead and reinstall the air filter assembly, and then it's just a matter of getting the panel back on the machine. bolts. And then the new assembly. Well, like I mentioned before, there are two, kind of depending on when you got the filters, differences in the lengths of the cables. I believe they all should be the newer, shorter cables. In some cases, it can be the much longer cable. So you'll be working again with the cable in the channel rather than just this portion. So maybe slight differences, but the overall process and the mounting system is the same. Let's put that back in there. Go ahead and reconnect our fan. Make sure that connection's stable. Get the back panel in there. And then reinstall the Phillips screws. And there we go. Get the bottom ones, just keep it stable for now. Filter replaced, and should be good. Turn it back on. Yeah, I do have air coming out of the back fan, so we are fully working again. Yep. So that's kind of a full rundown on the maintenance for the Pro 2s and replacing the consumable parts. And then kind of another thing that I wanted to talk about before we end the stream today, getting into the support that we offer and a lot of the other things beyond just the maintenance and guides. We do have a full technical team here in Irvine, California, that is always available to help with any kind of printer issues. If you're having trouble with prints, like I mentioned before, the bed level test is something we do. So we really, really want to be there with what you guys are doing. Essentially, the way that the support system is laid out, it is a bit different because we are, again, worldwide. So it does differ from region to region. If you're in the United States, we will typically run machines through direct sales. You can, of course, buy machines from us directly or from our website. We have a great sales team. And then you would come to us directly for any support that you would need. Again, we're always available. If you're buying through a reseller in the United States, we do always want to stick with the resellers first. So try and get support through them first, just wherever it's purchased from. And then for Europe and international partners, that also goes through resellers. And they have a little bit of a different setup where they specifically want to work with the resellers first. So if you do come to us, we will have to tell you to go to the reseller first for support. But we are always open to listening to what kind of experience you have, or if the reseller isn't up to your satisfaction, you can still come to us anyway. Let us know. We'll try and work with you as best we can. Just us with the machines, you as a customer, and then keeping the reseller involved to make sure that you are helped out to the best of everyone's ability and knowledge here. Just kind of another breakdown on that. Again, for the US, if you are buying from a reseller, best to go through them first. But you can also make a support ticket just at support.raise3d.com, looking for the option to make a new ticket, either up at the support tab at the top or at the bottom of the page. Then we can reach out to us. You can talk to us directly. Out in Europe, again, you want to reach out to the local reseller or find a distributor, somebody else who's local. Typically, the closer it is to you, the better it's going to be. And then again, if they are not meeting our expectations, do let us know, and we can work with the reseller to help you a little bit more. Then for international, again, still kind of works out the same. Local resellers, local distributors, or again, make a ticket to us. Let us know if you have not been properly helped. We can step in and give a little bit more where the distributor or reseller may have fallen short. Yeah, so that's going to do it for our stream today. I hope this has been helpful. And then if you guys do have any questions in the future, feel free to shoot us an email. If you want to pick up some spare parts to maintain your own machine, all of these are available on the website. Again, Our discount code for that is Filament, so you can go ahead and use that for any purchases. And we will see you in the next stream. Thanks everyone for joining us. I hope you guys have a great rest of your day.